Okay, so that's the theory in general, but for our purposes it's going to be a little bit different. So now we're going to move into specifically what this representative consumer we're talking about is going to do, and I'm going to show you two different presentations of it. So in one case, I'm going to show you first the analytical solution. So we're going to use math and equations to derive the solution to this consumer's problem. And it's going to be very similar to what we just did. And then second, I'm going to show you a solution that is graphical. So we're going to use graphs. And of course, in the end, the solution will be the same, but we're going to get to it in two different ways. And both will be important for our purposes. So let's start with this analytical solution. So as I said, we don't really care as macroeconomists necessarily about consumption of specific goods, of particular goods. We don't necessarily care how much someone spends on food versus movies or whatever. What we are interested in is macro variables, okay? And so two such macro variables might be how much do people consume, how much do households consume in general, and another macro variable is how much do they work, how much labor do they supply to the market. And as it turns out, we can represent both of these using very much the same methods we just saw. But now, consider a consumer purchasing consumption and leisure. So rather than movies and food, just change those two goods to consumption and leisure. So let's talk about exactly what I mean here. So this changes the consumer's problem to the following, okay? Maximize my utility, which is now a function of consumption, so how much goods I buy in general, how much money I choose to use to purchase goods and services, and then leisure. And by leisure, I mean how many hours in the day I spend not working. Okay, and so this is something that I derive utility from. You can imagine that the more hours I spend in leisure rather than in work, the higher is my utility, the better off I am. So now we have that the consumer maximizes their utility by choosing consumption and leisure. And now we're going to have two constraints. Okay, so the first one is this hours constraint. And it's going to say the following, that my total amount of leisure is total amount of hours in the day, H, minus the labor I choose to supply. Okay, so let me just write exactly what this is. This just says I divide my total hours, which is H, between leisure, which is L, and labor, which is NS, it's labor supplied. Okay. So that's one constraint. This is the hours constraint. And then the second one is going to be a budget constraint. Okay, so that's going to say the amount I consume is going to be equal to the amount I earn in labor income, so that's the wage times the amount of labor supplied, plus any profits I earn minus any taxes that I pay. Okay, so again, just let me quickly write this. So I consume C, I earn labor income, which is W and S. I receive profits, which is pi, and I pay taxes, T. So this becomes our consumer's problem now. And I'm going to show you that, in fact, it's very much the same, and the solution method, the algorithm that we employ, gives us the exact same kind of solution. So to do that, let's first combine those two constraints that we had. Okay, so just quickly remember what those were. We had our time constraint, which was my leisure is equal to total amount of hours minus the amount of time I spend working. And then also we had our budget constraint, which was my consumption is equal to my total income minus any taxes I pay. Now let's combine those. Okay, so we could solve for labor supply in the first equation and then plug that into the second one. And what do we get? We get that C is now equal to, so my total consumption is equal to H, total hours in the day minus leisure, plus profits, minus taxes. And we can rearrange this to make it kind of more similar to what we know before. So remember, we're still consuming two goods, but now our two goods are consumption and leisure. So let's put our purchases of those on to the left-hand side. So that becomes consumption plus W times L is equal to WH plus profits minus taxes. And now I claim that this is very much the same as the budget constraint we had in the general case. So on the right-hand side, this is just total income now. Okay, and I'm dividing it between the purchase of two goods. One is consumption, which has price equals to 1, and the other is leisure. The price of leisure is equal to the wage. So when I say the price of leisure is equal to the wage, what I really mean is that when I consume one more hour of leisure, what am I giving up? Well, I'm giving up what I would have got if I was working, which is the wage per hour, W. So if we think about it in that way then, that means that we can do the exact same conditions for optimality we had earlier. So we'll have the marginal utility of consumption divided by its price, which is just equal to 1, is equal to the marginal utility of leisure divided by its price, which we said is W. Okay, so that will be one of our conditions for optimality. We can write that kind of more intuitively, and I'll explain to you why it's more intuitive, just by moving the W term over to the other side. And that'll give us the following. MUC times W is equal to MUL. So why is this more intuitive? Well, let's just move this over for a second. And let's think about exactly what each side of this equation says. So this right-hand side, this is just the marginal utility of leisure. So this is the utility from working one more hour. Or sorry, from working one less hour, I should say. From working one less hour, and then using that hour for leisure activity. On the other side, we have, this is the utility I get from working one more hour, earning the wage W, and consuming W units. And these now have to be equal for the same reason as what we saw before in the general case. Okay, imagine they weren't equal. Imagine that we had, I'll write it out here, imagine that instead we had that the marginal utility of leisure is equal to 4, and the left-hand side is equal to 2. What does that mean? That means that I'm now better off working one less hour, which will sacrifice utility of 2, and consuming one more hour of leisure, which will more than compensate for the lost hour of labor and additional consumption that it gave me. So it's very much the same argument as what we saw before. Now I'm just expressing it not in terms of dollars spent, but in terms of hours either worked or used for leisure. And again, though, these marginal utilities, when adjusted for their prices, have to be equal, because if they're not, then I can readjust my budget, in this case, readjust my budget of hours to increase my utility. So all this is to say that our conditions for optimality become that and our budget constraint. And this is our combined budget constraint. These now define the optimality for this consumer, the optimal choice that the consumer can make.